Hello, this is Analog Circuits 18EC42, Module 3, Lecture 1, Feedback Amplifiers. We are discussing about today about the different exercises, the numericals in the Feedback Amplifier chapter. I'm Dr. Nurullah Sharif C, Professor at HOD, CCAB Institute of Engineering and Technology, Vijaypura. So the first problem here is concerned with the figure over here, and here we need to find first it says beta, and then we need to find when a is equal to 10 to the power of 4, we need to find r2 by r1, and when af is equal to 10, so given a equal to 10 to the power of 4, af equal to 10, find r2 by r1. C is what is the amount of feedback in decibels, the amount of feedback in decibels, about that. And then D is if Vs is equal to 1 volt, find V0, Vf, and Vi. If Vs is equal to 1, find V0, Vf, and Vi. Further, E is if A decreases by 20%, what is the corresponding decrease in the AF? So each one we'll try to find out. So feedback factor, the network for the feedback is this over here. So we have here V0, same thing is written here. This place is the place where it is Vf, this is Vf, right? So the beta is nothing but, the value of beta is nothing but Vf by V0. Vf by V0 is beta. And that value is so the value which is the Vf is nothing but the voltage across R1, and that is I into R1. And V0 is the voltage across R1 and R2 together. Same current is flowing through this. No current can enter the op-amp. No current can enter the op-amp. This is the basic trait of the op-amp. Op-amp has infinite input impedance, and that is also given there in the problem. Right? Infinite input impedance means no current flows here. Whatever current flows here comes out here. So V0 is equal to I into R1 plus R2, and that is written here. So having written that, we will get beta is equal to R1 by R1 plus R2. So that gives us the formula for beta. Then AF, B part is find AF when what you call find the value of R1 by R2 when AF is given as 10 and A is given as 10 to the power of 4. So 10 is there here, 10 to the power of 4, 1 plus a to the power 10 to the power of 4 by beta. That is the formula. In the formula we are substituting here. And if you cross multiply, then this will become 10 plus 10 to the power of 5 multiplied by beta equal to 10 to the power of 4. And the value of 10 to the power of 5 beta is equal to 9990, and hence beta will be equal to 0.0999. So having found the value of beta equal to 0.0999, we need to find the value of R1 by R2, and that is beta is equal to, we know, R1 by R1 plus R2. And if you take R1 plus R2 by R2, it is the inverse of this, then that will be 1 by beta is equal to this quantity, and that will be naturally R1 by this. You can write R1 by R2 plus R2 by R2 is 1, and R1 by R2 will be equal to this quantity minus the value here. The value, what you call 1 by 0.0999 minus 1. And that will give R1 by R2 is equal to 9.01. Then the feedback in decibels is 20 log 1 plus A beta, that is equal to 20 log A by AF, 20 log 10 to the power of 4 by 10. And this will give 10 cube, and that's why that 3 can be taken out here. log of a cube is equal to 3 log a, and therefore 20 into 3 will give us the value 60. So that will be 60 dBs. Then AF is equal to V naught by Vs. So Vs will be AF V naught, that is 10 into 1 equal to 10 will be the value of Vs. Sorry, this should be V naught. V naught is equal to AF into Vs. V naught should be equal to AF into Vs. And 10 into 1 equal to 10 volts is the V naught value. Then Vf is equal to beta V naught. Then V naught we have found here 10 volts. Beta we know 0.0999, that will give us 0.999. Then Vi is equal to Vs minus Vf. The Vs value is 1 and Vf value is 0.999, that will give us 0.001. Then the E is the percentage there, DAF by AF is equal to DA by A divided by 1 plus A beta. So if this is 20%, this quantity is 1 plus A beta is 1000, and that will give us 0.02%. Then the 8.2 is we are given the what you call gain as 10 to the power of 4, uniform minus 6 dB octaves. Please remember minus 6 dB octave is equal to minus 20 dB per decade. Same thing as minus 20 dB per decade. At a high frequency with 3 dB frequency of 100 Hertz, high frequency is 3 dB frequency of 100 Hertz. Find the low frequency gain. Low frequency gain has to be found, and upper 3 dB frequency has to be found of the closed loop amplifier with R1 equal to 1 and R2 equal to 9 in case of the circuit which is given above. So R1 is equal to R1 divided by R1 plus R2, 1 by 1 plus 9 is equal to 0.1. So AF will be A divided by 1 plus A beta. This is A divided by 1 plus A beta 10 to the power of 4 divided by 1 plus 10 to the power of 4 into 0.1. That will give 9.99. FHF is equal to FH into 1 plus A beta 100 into 1 plus 10 to the power of 4 into 0.1. That will be 100.1 kilohertz. Then the next problem, considering that the power output is equal to power output stage with the voltage gain A1 equal to 1 and input signal equal to Vs equal to 1 volt, and a hum of Vn, hum means noise, of 1 volt. Assume that the power stage is preceded by a small signal gain. You have a small signal gain, and this is the power amplifier which is having gain equal to 1, and this is the small signal amplifier which is having gain equal to 100. This is A2 and this is A1, and the overall feedback factor is beta equal to 1 is applied if the Vs and Vn remain unchanged. Find the signal and noise voltage to the output, and hence the improvement in signal to noise ratio. So now we have here this circuit over here. This is A2, this is A1, this is beta equal to 1. This is noise source which is entering at the center of this, and that will give us the V0S is equal to Vs into A1A2 divided by 1 plus A1A2 beta. So Vs is given as 1 volt, 100 into 1, A1 is 1 and A2 is 100 divided by 1 plus 100 into 1, that will give 100 by 101, that will be approximately equal to 1 itself. The noise voltage at the output is VON is equal to Vn into A1 divided by 1 plus A1 A2 beta, that is 1 into 1 divided by 1 plus 100 into 1 into 1, that approximately equal to 1 by, this is 1 by 101, that is approximately equal to 0.01. The signal to noise ratio formula is this: S by N ratio at the output divided by S by N ratio at the input is equal to A2 is equal to A2, and that is equal to 100, and that will give us in terms of dB as 20. Also, or otherwise we can try to write here VOS divided by VON. This is the signal to noise ratio at the output. VS by VN is the signal to noise ratio at the input. This is 1 by 0.1. This is 1 by 1, and that will give us the value which is 100. And that will give 20 log of 100 is equal to 40 dB. So 40 dB reduction. The fourth problem is if the op-amp of the example 8.1 has a uniform minus 6 dB per octave, again minus 20 dB per octave, high frequency roll-off with a f3 dB equal to 1 kilohertz, find the 3 dB frequency of the closed loop gain V0 by Vs. So 6 dB octave is 20 dB decade. FHF is equal to FH 1 plus A beta 1 kilohertz into 1 plus A beta is 7 in the problem given, and that is equal to 7 kilohertz. So in the example 8.1, we found that the value of the 1 plus A beta is 7, and that is why we are taking the 7 watt here. Okay. Next problem is the reconsider the circuit of 8.17A, this time with the output voltage taken at the emitter of Q3. In this case, the feedback can be considered to be the voltage mixing, voltage sampling type. Note, however, that the loop gain remains unchanged. Find the value A is equal to VE3 by VI, and AF is equal to VE3 by Vs, and the output resistance. So for this, we need to go back to the figure corresponding to the what you call amplifier at that time in the example given here. And in this example, you can see output is taken here. In place of this, now it says output should be taken at the emitter side. If you take that, then what really happens? So we have taken the gain to be equal to I0 by VC2. I'm sorry, A is equal to I0 dash by VI, and that we have found out to be 20.7. Now we want the gain to be I0 multiplied by this value, that is this voltage VE3, VE3 by VI, VE3 by VI is the value which we want to find, and that is equal to I0 dash multiplied by this resistance divided by VI dash. We know I0 dash by VI dash, and that is 20.7. That should be multiplied with this value, that is RE in parallel with RE1 plus RF. The same thing is being mentioned in the numerical over here. So I0 V3 by VI is equal to I0 dash by VI multiplied by RE2 in parallel with RE1 plus RF. And that is 20.7 multiplied by 100 into this is 100, this is 100, this is 640, and therefore this total is 740. 100 into 740 or 100, that will give 1824. That will give us the value 1824 as the value of this. Then we have to find the AF value. AF value is equal to A by 1 plus A beta, and 1 plus A beta we know that is equal to 247 in the earlier problem, 1 plus 20.7 into 11.9, beta was 11.9, and this value will give us 1824 divided by 247, that is equal to 7.3. Then we need to find R naught, going back to the what you call numerical there. R naught was this, and this R naught was with the view that this value was there because of the reason that we have taken the output here at this point. We have taken the output. Now we want to take the output here. Therefore, R naught, if we take it over here, then naturally the value will be RC2 translated on this side. Okay, RC2 translated on this side. That will give us what you call RC2 divided by HFE plus 1, and then the what you call the combination, which corresponds to the parallel combination of RE2 with this. So this is translated onto this side. That is what we had there. So that's why we had all this. Now what's happening? Because we are taking the output at this point, this will come in parallel with whatever is the what you call translated version. That means this will go to ground, and that will R is RC2 divided by RC2 divided by HFE plus 1 and the RE3. All that should be considered because we are trying to replace this transistor by the model, which is this. So we are trying to replace this by this. So that's why if we take here RE, and that is connected to RC2. RC2 current flowing is the current which we should consider IB, because that is to be analysis, it will be grounded. But if it's brought onto the emitter side, that will become RC2 divided by HFE plus 1. So therefore, the quantity here, which is there, will come in parallel with. Now, because we are taking out the output at this point, we will have this quantity in parallel with this quantity. So in the what we call numerical going back, we'll see that the value of RE2 in parallel with RF plus RE1 in parallel with RA2 plus RC2 by HFE plus 1. So this quantity is 88 and this quantity is approximately 56. If you take the parallel combination, we'll get 34. ROF will be equal to RO divided by 1 plus A beta, because now we are talking about the voltage mixing, voltage sampling. So the value of the voltage sampling is being considered here. Voltage sampling means naturally R naught will be divided by 1 plus A beta. And that will be 34 divided by 247. That will give you 0.14 ohms. 0.14 ohms. The other way of telling this is because we are taking out output per the emitter, the last stage of the circuit over there will is a last stage of the circuit over there is a what you call emitter follower, common collector. We are taking output here, so it will act as emitter follower. In the earlier case, it was acting like a common emitter. Now it is common collector or emitter follower. For emitter follower, the output impedance is very, very small, and that is why we are getting the value there as the 0.14 ohms. Then we have here a negative feedback amplifier has a closed loop gain of AF equal to 100 and open loop gain of 10 to the power 5. Then we need to find the factor beta. If the manufacturing error results in a reduction of A to 10 to the power of 3, what closed loop gain results? What is the percentage of change in AF? So the first part is we need to find beta 100 10 to the power 5 divided by 1 plus 10 to the power 5 beta. Cross multiplying, you'll get 100 plus 10 to the power 7 beta equal to 10 to the power 5. 10 to the power 7 beta will be equal to 10 to the power 5 minus 100, that will be 99900. Beta will be 99900 divided by 10 to the power 7, that will give you 0.00999, or you can say 0.001 approximately. And if A is 10 to the power 3, then naturally AF will be 10 to the power 3 divided by 1 plus 10 to the power 3 into 0.0009, and that will give 10 cubed by 10.99, and that will be 90.99. The percentage change in AF will be 100 minus 90.99. Earlier it was AF was 100. AF was considered 100. That is what we have written here. Now it has become the value 90.99 divided by 100 into 100. That will give us 9.01, or just approximately 9%. Next, we have the non-inverting amplifier, non-inverting buffer op amp configuration. Buffer just means output is connected to input over here. The output is connected to input is buffer will give an amplification which is 1, output impedance is low, and input impedance is large for this. So now we have here what you call in the 8.4 this overall thing, assuming that the op amp has an infinite input resistance and zero output resistance. What is beta? If A is equal to 100, what is the closed loop gain? What is the amount of feedback in dBs? For Vs equal to 1 volt, find V0 and Vf. If A decreases by 10%, what is the corresponding F? So this problem is almost same as the earlier problem, except that in place of the non-inverting amplifier, we are having a buffer. So now the V is equal to Vf by V0. This is V0 and this point is Vf. Both are connected together. Beta is equal to V0 by Vf by V0 equal to 1. So AF is equal to A by 1 plus A beta, 100 by 1 plus 100 into 1. That will give AF equal to 0.99. So having got the value of AF equal to 0.99, feedback in decibels will be equal to 20 log of 1 plus A beta equal to 20 log of 101. This is A beta, that is 101, or it can be considered as 100 by 0.99 also, A by AF also. That is equal to 40.09 dBs. If Vs is equal to 1 volt, V0 will be equal to AF into Vs equal to 0.99 multiplied by 1, that will be 0.99 volts. If then Vi is equal to Vs minus Vf, that is Vf is nothing but V0, Vs minus V0, 1 minus 0.99, that will give IVI value equal to 0.1. Then the change in the what you call AF compared to the change in A is written with this formula divided by 1 plus A beta, 10% divided by 101, that will give us the value 0.099 or just 0.1 approximately. So this finishes the numericals. However, if there are some more numericals, we will take in the next recording.